Good morning to everyone. Today I am going to explain concept about fuel cell. What is fuel cell? A fuel cell is a device that converts chemical potential energy into electrical energy. What is chemical potential energy? The energy stored in a molecular bond is called chemical potential energy. So, a fuel cell is converting the chemical potential energy into electrical energy. Unlike a generator, a fuel cell directly converts an energy source into electricity through the chemical reaction. This involves one step rather than multiple steps. This allows a fuel cell to remain efficient, quiet and clean. So the fuel cells are classified into so many types: polymer electrolyte membrane fuel cell, direct methanol fuel cell, alkaline fuel cell, phosphoric acid fuel cell, molten carbonate fuel cell, solid oxide fuel cell, reversible fuel cell. So these are all the types. And what is the difference between fuel cell and battery? The biggest difference between the two is that a battery stores energy while a fuel cell generates energy by converting available fuel. A fuel cell can have a battery as a system component to store the electricity when it's generating. So this is the main difference between fuel cell and battery. Advantages of fuel cells. Fuel cells eliminate pollution caused by burning fossil fuels. The only byproduct is water. This is one of the major advantages of fuel cell. The maintenance of the fuel cell is very simple since there are very few moving parts in the system. Therefore, the maintenance of the fuels is very simple. Use variety of fuels, renewable energy and clean fossil fuels. Fuel cells can be responsive to changing electrical loads. Then fuel cells provides high quality DC power. So these are all the advantages of fuel cells. Disadvantages. Initial cost is high and the fuel cells are currently very expensive to produce since most units are man-made. So this is one of the major disadvantages. And then service life is low and operations requires frequent fuel supply. And similarly, the technology is not yet fully developed and only the few things are available. So these are all the disadvantages of fuel cells. So already we discussed in the previous slide that there are so many types of fuel cells are available. So mainly the fuel cells are classified by the kind of electrolyte they employed. So the electrolyte plays a very key role. It must permit only the appropriate ions to pass between the anode and cathode. If the free electrons or other substances could travel through the electrolyte, that would disturb the chemical reaction. So whether they combine at anode or cathode, together hydrogen and oxygen form water which drains from the cell. As long as a fuel cell is supplied with hydrogen and oxygen, it will generate electricity. So the first type of fuel cell is polymer electrolyte membrane cell. Shortly it is called as PEM fuel cell. So the figure shows that some of the basic elements which are used in the PEM fuel cell is anode, cathode and PEM, nothing but proton exchange membrane cell. So a PEM cell uses hydrogen gas and oxygen gas as fuel. The products of the reaction in the cell are water, electricity, and heat. So, in the anode side, we may supply hydrogen, and the cathode side, the oxygen is taken from the atmospheric air. So, when we are passing the hydrogen through anode side, it may be splitted into hydrogen ion and electron ion. The membrane is allowing only the hydrogen ion to the cathode side, and whereas the electron is passing through external circuit, so that the electricity is taken, and once again the free electron is passing through cathode side through the external circuit. So here the platinum is the most common catalyst material used at the anode and cathode. So here I am going to explain the working of FEM fuel cell. The pressurized hydrogen gas entering the fuel cell and the anode side. So this gas is forced through the catalyst by the pressure. When an H2 molecule comes in contact with the platinum on the catalyst, it splits into two H plus ions and two electrons. So the electrons are conducted through the anode, where they make their way through the external circuit. That means doing a useful work such as turning a motor, and return to cathode side of the fuel cell. Meanwhile, on the cathode side of the fuel cell, oxygen gas is being forced through the catalyst, where it forms two oxygen atoms. Each of these atoms has a strong negative charge. This negative charge attracts the two H plus ions through the membrane, where they combine with an oxygen atom and two of the electrons from the external circuit to form a water molecule H2O. So the figure explains that the stage by step process which is involving in the FEM membrane fuel cell. Then the next type of fuel cell is alkali fuel cells. So these type of fuel cells also operates an compressed hydrogen and oxygen. They generally use a solution of potassium hydroxide. So the notation of the potassium hydroxide is KOH. Is mixed with the water as their electrolyte. So the efficiency about this alkali fuel cell is 70%, and the operating temperature is between 150 to 200 degree Celsius. In these cells, hydroxyl ions migrate from the cathode to the anode. At the anode, the hydrogen gas reacts with the hydroxyl ions to produce water and release electrons. So the electrons generated at the anode side supply electrical power to an external circuit, then once again it is returned to the cathode. There the electron react with the oxygen and water to produce more hydroxyl ion that diffuse into the electrolyte. Alkali cells were used in Apollo spacecraft to provide both electricity and drinking water. Normally, nickel or platinum or palladium is used for both anode and cathode material. The next type of fuel cell is molten carbonate fuel cells. Molten carbonate fuel cells, shortly called as MCFC, it uses high temperature components of salt like sodium or magnesium carbonates. it is called as CO3 as the electrolyte. The efficiency ranges from 60 to 80 percentage, and the operating temperature is about 650 degrees Celsius. The salts melt and conduct carbonate ions CO3 from the cathode to anode, which is shown in the figure. At the anode, the hydrogen reacts with ions to produce water, carbon dioxide, and electrons. The electrons travel through an external circuit, providing electrical power along the way and return to the cathode, which is clearly shown in the figure. There, oxygen from air and the carbon dioxide recycled from the anode react with the electrons to form carbonate ions that replenish the electrolyte and transfer current through the fuel cell. Molten carbonate fuel cells demand such high operating temperatures that most applications for the kind of cell are limited to large stationary power plants. Nickel or chromium or aluminium material used as anode, and nickel oxide or lithium material is used as the cathode for molten carbonate fuel cells.